Hey guys, I'm Eric at AeroGuard Flight Training Center, and today we are going to talk a little bit about weather. Specifically, I want to create sort of a systematic approach to making our go or no-go decision for the flight, specifically around weather. I understand that there might be other variables that could affect your go or no-go decision. I just want to focus in specifically on the weather aspect for this video. We're going to follow the same standard briefing model that's in the AIM in Chapter 7. And so it follows a sequence like this. I know that there are a few more items that are generally included in a standard briefing, but those aren't applicable to the weather. So I just left the first 6 that are related to the weather. So what I want to do is kind of create a sort of systematic approach to work through each of these things and ultimately identify whether it's safe for us to go on this flight or not. I will be using ForeFlight for all of the weather information that we're going to receive today. So let's jump over to the iPad and take a look at what we're going to check out.
Okay, so over to ForeFlight here, and what we see is sort of an example flight that I've put together that we're going to walk through this weather briefing with. So in this example, we are choosing a departure airport of San Angelo, Texas, and flying to Waco, Texas. So I did a little bit of preliminary work and decided, based on the direction of flight being mostly to the east and obstacle avoidance, we want a minimum cruising altitude of around 5,500 feet. And then we planned for a departure time around 1830 Zulu, and that based on the winds should put us at arrival time around 2000 Zulu. So those are the things we're going to want to keep in mind as we walk through this weather briefing. So first way that we're going to start is by identifying any adverse weather that might immediately just rule out the opportunity for us to do this particular planned flight. So to do that, we're going to immediately look at airmets and sigmets, right, and convective sigmets. So let's jump over to this imagery tab, and specifically what I have done is just navigated to this advisories section, and we see the graphical airmets here. So we're going to go through each of these different airmets, and we can also look at the sigmets. So what we'll do is we can start first with we'll start with the airmet Sierras. So for IFR conditions or mountain obscurations, and what we'll look at is we notice that there are several of these forecasts available, and they're trying to identify what it would look like at different times. So how do we know what the valid times are for each one? If I simply go into the first one here, the Sierra Initial, I'll notice in the top right corner it says the valid time is 1500 Zulu. So this is attempting to show you what it would look like at 1500 Zulu. Obviously our planned flight time, as I said, was 1830, so this is quite a bit before our departure time. Let's see. If we go 3 hours later, the valid time for this is 1800. So I think that that's at least closer to where our departure time would be. And then obviously the 6-hour one would be 3 more hours after that. So I think the most appropriate for our purposes would be this 6-hour forecast and the 3-hour forecast. So for each of the different airmets, we can look at both and sort of compare, since our flight is planning to operate between those two valid times. What we'll do is we'll take a look first at these airmet Sierras, and it does identify that there is a possibility of IFR conditions sort of in the middle of Texas there, so we'll have to see for sure exactly where that is going to be. And then it appears as though it seems to be moving to the east. If I compare the 1800 valid time airmet Sierra to this 2100 valid time airmet Sierra. So what that means to me then is potentially this may be cleared out by the time we get there, but we'll look at the TAF for our destination just to see what the weather will eventually look like. Moving on then, we can look at the AirMet Zulus. So it does identify icing conditions, but only from 20,000 to 28,000 feet. So not a significant factor for us, since we're definitely not going to those altitudes. And the 6 hour, basically the same deal. So once again, not a factor there. The last one would be the AirMet Tango. This would be for turbulence. This looks pretty significant. So there is a bunch of various different pockets here. It appears as though there are two that really stand out to me. So we see one section that kind of overlaps a lot of Texas and Oklahoma and Arkansas, and that one is from the surface to 18,000 feet. There's moderate turbulence, so we'll have to watch out for that. And then we see on the east side of Texas, there's this little dark red area. It says low-level wind shear. So that'll also be interesting. It seems as though I'm getting the idea, at least, that obviously there must be more significant weather on the east side of Texas right now. We can also look at the 6 hour, and we see it's basically the same kind of idea. It may have expanded or moved a little bit further to the east, but still the similar kind of concept. So that seems to indicate that we should be conscious of the fact that there's probably some weather, it appears, on the east side of Texas right now. So from the AirMets, we can jump to the SIGMETs, so we'll go down to the next one below that. And they have them divided up, but we can also just go to the all section, and this is all of those SIGMETs, including those convective SIGMETs. And we notice, yep, so east side of Texas has kind of an outlook, which is the orange box, and then there's a red section there of an active convective SIGMET going on. So definitely we'll want to see where that applies specifically to our route of flight, and make sure that it's not appropriate or not interacting with our route of flight. So real quick, what I want to do then is something I like to do is, as I go through each of these phases, in my scratch pad or on a separate piece of paper or wherever, I'm just going to kind of write my own little notes as I go along here. So adverse weather, I would say the AirMets. Really the only thing that was significant was moderate turbulence and possible convective activity. Good. So now I'm also going to go up and look at the significant weather outlook charts, right? So specifically what I care about now is, once again, this should be a picture of two different images kind of forecasting now and later, or point in time and then a later point in time. So in this case, the picture on the left has a valid time of 1800 Zulu today, and the picture on the right has a valid time of 0600 Zulu the following day. So this would identify how they imagine this will move over the next 12 hours. And really all this does is help confirm for us. If we look at the image on the left, we can identify that they identify that a big portion of the eastern portion of Texas is IFR, and just outside of that is the blue scalloped line, which would identify an area of marginal VFR conditions. So very similar to like what we had seen from the others. We see this array of moderate turbulence and possibility of IFR conditions or that could exist along our route of flight. So this is just one more image that we can use to kind of reinforce what we already saw from the AirMets, SIGMETs, and convective signets. Next, we'll jump over to the synopsis. For the synopsis, what we're going to do is we're going to start with these prognostic charts. They're basically like visual representations of what we could read from an area forecast, and I like the visual side. So we're going to select this 6-hour forecast, and the first thing that I want to check is at the bottom of this prognostic chart. I'm going to verify the valid time, right? So we notice that it says it's valid at 1800 Zulu. We remember that our flight, the departure time is approximately 1830 Zulu. So this is depicting what the weather should look like approximately at that time, at least on a large scale. And so what do we see when we look at this? So we see that there's kind of a cold front and this warm front, and we notice that there is a significant area of green, which is chances of rain, and a lot of areas that are likely rain, and then this big red area, which is obviously an area that they're identifying potential convective activity. And where these two fronts are merging, that tends to make a lot of sense. And all of that is taking place on the eastern portion of Texas, which is pretty close to where our destination is. So that leads me to believe that as we continue to look further at our en route and destination forecasts, we'll want to check on specifically where the convective activity is, where these thunderstorms are, and ensure that it's not going to affect our route of flight. Okay, so what I want to do then is move back to our scratch pad here, and under synopsis, I'm going to identify the things we want to remember to pay attention to. So the first piece is there's a huge area of rain where these fronts are converging, and so that leads me to believe that possibly we could encounter low ceilings, so we'll want to watch out for that. And second, we'll also want to take a look at specifically where some of the convective activity or these thunderstorms are, and make sure that they're not at our destination or over the course of our flight. Good, so now we can move on to the current conditions. From the synopsis, we're going to move on to current conditions, and specifically what I care about is current conditions mostly at our departure airport and around our departure area, as we're going to use the forecast later to identify closer to our destination. So one quick way to do that is to simply go to the Maps tab here, and we can just touch on our departure airport, and then at the bottom there it says METAR. So this is a real quick, easy way to get immediate conditions that exist at our departure airport. As we see, it's pretty good VFR conditions, right? So winds out of the west at 10 knots, so 10-mile visibility, it's sky clear, pretty large temperature dew point spread. All of that looks great. Not too much, it seems, to really worry about here. So that must be outside of our area that we had discussed before. So that looks good. And one other piece that I think is really valuable is PIREPs. So weather reports given by pilots that are flying around. So to access those PIREPs, we can do this a couple of different ways. One of the ways that we can do that is, once again, we can go to the Imagery tab, and we can navigate down to this Pilot Weather Reports section and simply select PIREPs. And obviously we see that there are many different options available. One easy way, either we can select the whole country per topic, like icing or turbulence, or the sky condition, or we can select our specific area, our region. So in this case, in Texas, we'd be in the south central region, so it would be SC. So we wanted to see any icing issues. We could simply look here. Once again, we already knew about those. That's all well above the altitude we'll be flying at, and we knew that that was forecasted in the AirMet. And then we can look at, once again, turbulence. So we can look at turbulence for South Central. We knew that there was moderate turbulence according to the AirMets. These guys are reporting turbulence pretty similarly, it appears. So it looks like we can safely assume that during our flight we could expect moderate turbulence at any of the altitudes that we're going to be flying at. Okay, if we go back out of the turbulence, and now we can go on to the weather and sky condition side. So we can once again select the South Central weather and sky condition. There's a little bit of a key down below, but for the most part, it looks like they're all just identifying ceilings, and it does look like they are experiencing some pretty low overcast cloud layers in the Dallas area, and then south of the Dallas area. Looks like 1,200 feet at an area that might be fairly close to our destination. So that will definitely be something for us to keep in mind. Good. So that basically wraps up the current conditions side. Now what we want to do is move into the forecasted side. To talk about the en route forecasts, once again, I'm going to want to look mostly at graphical representations of these things. So in the imagery tab of ForeFlight here, we can scroll up to this section that says Graphical Aviation Forecasts. And we notice there are a bunch of different options available. So we can look at a few different things, right? One is we can look at the clouds across the entire country, or once again, we could look at specific regions as well. So for the cloud coverage portion, I think what we'll do is once again find our region, South Central, and we'll select that. And then we can simply go in and see the different validities and confirm that we're looking at the correct one. So in this case, for example, in the upper right corner, we see that it's predicting the weather for today at 1800 Zulu. So once again, this is just before our departure time. So this will give us a pretty good idea of what the weather should look like across the area. And as we see, we do identify that the weather closer to our destination there in the east side of Texas is probably going to look to have overcast layers pretty low, maybe in the marginal VFR range to the IFR range. So this continues to kind of paint this picture for us. It looks like we could anticipate pretty low clouds as we get closer to our destination. So the next thing that we can certainly check out is the surface conditions. So South Central and then surface. And once again, we'll select the 3 hour and verify that it has the correct valid time. It does. And once again, we see a bunch of potential convective activity. So I think this has been pretty clear in identifying that our destination probably is going to have some pretty severe weather. That's the inclination that I'm getting right now. I think we'll hone in specifically with our destination information. So let's switch over to that now. Okay, so let's go look at the forecasted weather for our destination. So from this imagery tab, I'm going to go back to our maps page. And now what I want to do is go on ahead and take a look at our destination. So I'm simply going to touch our destination, go to forecast, and we can see the TAF there is available. So right away we see right now it's presently forecasting and that we should probably see overcast at 1,500 feet, so marginal VFR, and that will basically persist until the next line, which starts at 2,200 Zulu today, which is beyond where we're planning to fly. So we could anticipate marginal VFR conditions with a pretty low ceiling at our destination. We also know that there are showers in the vicinity, and we know that there were some thunderstorms around, so we may want to actually see more specifically where that is. So what we can do is this. What we can do is on this maps page, we can start to overlay some of those other that other information to identify where some of that precipitation is, for example. So I can add this radar overlay, and we can see pretty quickly that there is some rain showers to the east of our airport. So that's okay for sure. We can also see that if we can also check out some of the other existing conditions around some of the airports that are along or close to our flight path. We can do that by once again selecting the flight category, and we notice that weather seems to be pretty clear along our route of flight until we get pretty close to our destination, and once again we get into this marginal VFR situation. So I think it is safe to say that we should be clear of any of these thunderstorms. As we see, there are several of these pockets of thunderstorms that are all moving to the northeast, so those will probably stay out of our way. But this ceiling condition may be a bit of a challenge. Okay, for the last bit of weather information, we're going to check out the Winds Aloft. We can get this a few different ways, but I've already sort of loaded this kind of preliminary flight plan into the flights section and received a briefing. And I think one of the easiest ways then is to simply check out the Winds Aloft, and there's various places we can go, but this seems like the easiest way, either visually or the Winds Aloft table here. And in either case, we see that the winds are basically out of the west, so we're going to have a tailwind for most of the time, which is going to be good in having a faster ground speed for us. And this might just help us potentially in determining an altitude that we'd want to climb to, or something to that effect, whether we want 5,500 feet or 7,500 feet or whichever. And so I think we'll be fine with the 5,500 feet, and that looks easy enough. So I think our biggest takeaway, if I go back to our tab here and we write in our tailwind, what we see then is this. We see a consistent message. We were a little bit concerned with some of the convective activity that was going on early on in some of our initial information. But eventually, I think what we discovered is that I don't think the thunderstorms would be too much of an issue. I think we can expect some turbulence along the flight, and I think the biggest thing that stands out is the ceiling. In this particular case, it looks like we'd have to descend to about 1,000 feet above the ground for the last, probably around the last maybe 20 miles or 30 miles of the flight. If that's the case, that's quite a bit of time to be traveling at a relatively low altitude. I personally am not a very big fan of flying that low. I probably then would either opt to do this flight at a later time, maybe as the weather continues to clear up, or maybe elect to not go on this particular flight today. But obviously it's possible you could do it. I just don't know how comfortable I would be at flying 1,000 feet above the ground for an extended period of time. So that concludes each of our sections here. We've gone through everything, and I think we've been able to deduce pretty realistically that we could possibly go on the flight, and it's more about maybe your own comfort level, specifically around those ceilings.
Thank you very much for joining us. Hopefully this was insightful, and we covered a bunch of information about how to navigate through all of this weather information to help you make the best go or no-go decision you can. Don't forget to like and subscribe for more video content like this that we produce every week. Look forward to seeing you soon. Thanks.